is energy, climate change in China. Is there hope for averting environmental crises? I'll let you decide at the end of the talk how much hope we have. Before I get into this, Mark Alper had asked me to say a few words about how I ended up in this field. I got a PhD in chemistry from UC Berkeley, and what I will talk about is not chemistry. In the 60s, when I was at Berkeley, a number of us felt that a science background was a terrific background because of the quantitative and experience of learning really difficult things. But it was a background far better than, let's say, a lawyer for looking at impact of science on society. I got intrigued by that to the point where we were permitted to organize a course at Berkeley. There were 6 of us graduate students. There were 120 students, because that was the number I needed to get the 19 faculty members who had committed to leading a discussion group every week on a subject about which they knew only a little bit more than the students, unless some of them prepared better than some of the students. So they had dialogue on key issues on science and society. The area I covered at that time and learned a whole lot about was radiation effects and what you do about it. That was exciting. And I realized that I wanted to use my science to do something that had impacts in the world. And at that time there were, and this is 1972, none of you are old enough to remember the embargo in 1973. This is before energy was even an issue in the United States. And it was either going to be that or weapons, and I concluded that I couldn't have much impact on the weapons problem, and I might have a little more impact on energy. So that's how I got into it. Now, as to how we got into China, the China group, I'm going to also say a few words about the China group, and then we'll get into the talk. The China group exists at Lawrence Berkeley National Lab, and it was formed in 1988. It was formed at a time when the Chinese had no dealings with any country outside of China on energy efficiency. Ironically, when I went to China, I discovered that energy efficiency, and this is something I don't think that's recognized much in this country, was a very high priority of the Chinese, but they did it all themselves. And they did not collaborate with others. They didn't know what was going on. They invented approaches that no one had done at that time. I'll get into that a little bit. So we've had this group continuously since 1988. All our work is done collaboratively with Chinese, and this indicates the general objectives of the group. What we do specifically is we analyze, for purposes of their adopting policy, on energy efficiency in buildings, in building equipment, in industry, and then various cross-cutting activities that relate to longer-term policy. And we've been very involved in creating institutions that are now central to China's efforts to address energy efficiency. So it's been a fascinating ride working with the Chinese. And I know many people in other areas who work with China, and I would say my experience, many people have good experiences, but mine have been particularly good in a policy arena because we're working in an area that they want to advance in. So our interests, we have interests in common, and I think we've had some real impacts. What have we achieved? Well, we're interested in saving energy and reducing greenhouse gas emissions. The best, by far, way to reduce greenhouse gas emissions is not to have to use energy. So you don't cut them by a little bit. Every kilowatt hour you don't use is a reduction in molecules of CO2 that you would otherwise emit. The other thing that's special about energy efficiency is that there's very large amounts of it that pay for itself, but people don't know where it is or what to do. And so if you organize policies, that really guides people into investment in energy efficiency that pays off. And that's going to be an important theme in the discussion. Well, we've brought appliance efficiency standards. By the way, any questions during this, please feel free to ask, particularly questions of clarity or whatever. We brought appliance efficiency standards to China. In terms of CO2 emissions, by 2020, it will have, if you value CO2 at what is its, until recently, current price of $20 a ton on the world market, now it's lower because of the serious global recession where economies really aren't producing, using as much energy as expected. But if you valued it at $20 a ton, this investment in training the Chinese to do appliance standards has resulted in will result in a reduction of CO2 emissions worth $70 billion by 2020. So this is an investment, and this is a theme I want to get to at the end if I ever get to the end, but very important. Investing in capability in training is a very low-cost way to achieve reductions in greenhouse gas emissions. This cost probably $7 million and will result in a savings of, if you valued CO2 at $20 a ton, $70 billion, a factor of 1,000 return. Have that big a return? Well, the answer is that the training and the policy cause investments to be made by consumers, and those investments result in more efficient appliances, which result in less energy use, which result in CO2 savings. So that you're paying for this little tip of the iceberg that makes possible a chain of events that leads to very substantial savings. I'll give one more example from our work. This was done by my colleague Lynn Price. She had this idea based on work that approaches that had been taken in the Netherlands and UK, that an interesting and in those countries successful approach to saving industrial energy use was to get the industries to negotiate a voluntary agreement with the government. And the government would provide certain technical support in exchange for the agreement. And the agreement in the Netherlands was done both at a plant level, a steel company, or for the whole industry. And the Netherlands has they started with a very efficient industry, and they've had the highest improvement in efficiency of any industrial country through that program. So my colleague Lynn Price thought, boy, that would be interesting to try to take to China. And the Chinese said, no way. And they said, no way, every time she tried, and she kept trying. And finally, she arranged a trip for very senior people involved in industrial energy policy to go to Europe, and they went and they poked around and they said, wow, you know, that's pretty interesting. So then she did a trial with 2 steel mills in Shandong province, not too far from Beijing. And they committed to 15% reduction in energy intensity in 3 years, which had never been done before in China. And the government committed to sending technical experts and publicizing widely their success or failure. They succeeded. And I'm anticipating the story, but it'll save me time later. For various reasons, the Chinese had to ran into big trouble that I'll tell you about, and this was the basis for a huge national program to save energy in industry. So these are contributions that we have in the past made. Of course, everybody says, "What did you do for me yesterday?" So they count for something, but not everything. These are the people in the group, so there are 8 of us. I have to confess, I was the only one who didn't speak Chinese. I always had someone to translate for me. It's a shame, but I got into this a little late, and maybe I can retire part-time and work to learn Chinese. It may not be too late. And then a very talented other person came into the group and convinced me, Lynn Price, and she doesn't speak Chinese. Everybody else speaks and reads Chinese. Okay, substance. Why worry about climate change? Why worry about China? What does that have to do with any of this? And what can be done? Okay. Many of you may have seen these, but it's really worth looking at many, many times. Is there a pointer that I... There's not, okay. Oh, wait a second, I know. How about this? Everybody see that? Okay. Look, that's a pretty straight line, and then woo, goes way up. Okay. And this is, you know, like 1850 when it starts going up. What do you think happened around 1850? Yeah. So you think there's a chance that might be caused by people? Yeah. Well, I got to tell you, until the Intergovernmental Panel on Climate Change came along, there was a substantial body of folks out there, I would call most of them pseudoscientists, who said, no, we can think of many other ways that you don't know that it's people. Well, turns out you can actually trace CO2 by isotopic constitution to different sources. And so you can show that there's this CO2 over a big industrial area in what used to be Pittsburgh, China, and it came from there. And there's no doubt this all came from, virtually all of this came from man-made activity. Same thing with methane, although cows, animals contribute there, but that's related to us too. This is also was very controversial. There were lots of naysayers. People disputed that the Earth was in fact getting hotter. Well, these data are now strongly confirmed from multiple sources and consistent, and the globe is getting hotter. Let people who say it isn't true, I urge you to recommend they go to the most authoritative source on all this and very cautious source, the Intergovernmental Panel on Climate Change. This is a group of international scientists, more than 1,000, who work on this review and updating of everything that is known about climate change on roughly a 5-year period. And basically dispel myths through their caution and care. And so now those are thick documents, but they've been reviewed by all the major governments, the summaries, line by line. I went to Bangkok and I had to sit through a 5-day session where the summary for policymakers We went through it line by line, and people were, you know, well, on that occasion I found the Chinese to be somewhat difficult. Turns out their lead guy didn't understand the topic, as I knew a number of the other people in their delegation. Made it hard. Anyway, very carefully worked out stuff. Yes?
There seems to be a dip in the 1960s. Is that statistical, or is that meaningful?
I think that some of that was what's that? One of the volcanoes. And for some years, it resulted in cooling. And then some of it is fluctuations. So, I just want you to see two very strong statements from the IPCC. The warming of the climate system is unequivocal, as is now evident from observations of increases in global average air and ocean temperatures, widespread melting of snow and ice, and rising global average sea level. When they state unequivocal, it means that the 200 scientists in IPCC who are most knowledgeable about this will stake their scientific reputations on the accuracy of the statement. Unequivocal is a word not used very often. Most of the observed increase in global average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. That is due to emissions from human activities. Now, 7 years before, the IPCC could not say that. They said we suspect that this is true. So science played a very important role in advancing understanding. So the warming is caused by humans, and humans produce these chemicals which really cause a greenhouse that absorbs radiation and emits it as infrared radiation to the Earth. It's interesting, there are some things that are cooling, there are some things that are heating. The heating way wins out, and it turns out by chance that the CO2 is a surrogate for everything that's going on in terms of, this is called radiative forcing. It's the impingement of energy on an area. So CO2 is a surrogate for a whole range of CO2 emission, of greenhouse gas emissions. So we'll generally talk about CO2 or CO2 equivalent. Let's look at temperature. Here's the temperature today, and you'll know, many of you will know this. How many saw Al Gore's movie? Okay, so this is a refresher course from Al Gore. How many of you have seen this chart? Okay, so it's worth going over it. That's a small percentage. Look, today, temperature is higher than it's been in 1,000 years, the average temperature in the globe. And we have a range of projections that in the high case by 2100 would be 5 degrees centigrade. How much is that Fahrenheit? How much? 9? Yeah, something like that. It's a lot. Okay? And the low of the analyses that were done has it only going up 2 degrees, okay? Which some people say is acceptable, but we'll talk about where that low came from. The models have improved a great deal in agreement with measurements. The top chart shows you the observations, and the model runs without greenhouse gases. Where's my, yeah. And so if we don't put in the greenhouse gases and increase the greenhouse, we get something that shows a lot of variation from year to year, but doesn't show any trend line, when in reality, this is what has happened. So if we put the greenhouse gases in, and we put some other things in, it turns out there's an intermediate step here that was omitted. After this was done, they put greenhouse gases in, and they omitted the emission of sulfates and other particles that end up reflecting and are cooling. And so for some time, agreement wasn't so very good even when you put the greenhouse gases in. And that's a very encouraging thing, because when you put another thing in that you know is there, and you get much better agreement, that gives you considerably more confidence in the models. The models seem to work quite well at a global level, and they're not so terrific as yet at predicting regional impacts, and that's a big problem. So what is climate, and why do we worry about it? And here I want to dispel what I think is a misunderstanding. People think of climate effects in terms of this change in temperature, and of course that's what I talked about. That's a way of measuring what's going on with climate. But in fact, it's other things that are happening due to that increase in temperature that you really care about. For example, warming, the greenhouse gas will cause many areas of the world to increase in temperature, and areas of the world to decrease in temperature. And so the average warming temperature is a low estimate of the impact of temperature, because there is cooling. And so there has to be more warming than the average. And furthermore, the variations increase very dramatically. It changes the cloud cover, which changes, it changes water in a very significant way. It changes snowfall. Predictions are that California in the next 50 years, if things go as they're going, could lose almost all of its snowpack. Forget about skiing and worry a lot about how we're going to store our water and make it available when we need it. Huge problem. When climate changes, the patterns change. What does it put at risk? Availability of water, productivity of farms, forests, fisheries. I was on BART yesterday and talked to a woman from the Coastal Commission. They're trying to understand what the effect of climate change would be on inland waterways. And unfortunately, the models aren't good enough to give them answers yet, but they're very concerned about that. Prevalence of oppressive heat and humidity. We've had some extraordinary heat waves that have killed a lot of people already. At this point, probably a majority of climate scientists think that that's due to climate change, but you can't prove it yet. I would say that many climate scientists, I've been in the Intergovernmental Panel on Climate Change for 3 of their reports, so that's 17 years. And I have to say that very few scientists expected to see the impacts so early that we're seeing. And in many ways that's a good thing, because maybe we'll do something if we see impacts. Geography of disease, damages from storms, floods, droughts, wildfires, property losses from sea level rise, and that's a sleeper. That could be very serious. And species loss. So you really have it affecting everything. For example, coral reefs. We know already that coral reefs throughout the world are dying out. I think something on the order of 25% of the coral reefs are now very severely damaged by hotter ocean water. And that's where most of the heat goes, into the ocean. Here's an interesting picture. This is a glacier on Mount Everest, taken at the same time of the year in 1968 and 2007. You see any difference between those two? Yeah, snow. This is a big deal. There are something like, there's more than 2 billion people who are dependent on the glaciers in the Himalayas, in China, India, and if those glaciers decline in size, and they will, a water-scarce area is going to become more scarce indeed. Here's another picture, 1910 to 1997. So these things are happening. Now, here's the big thing that's happened since the IPCC report. The IPCC report, none of the models looked at the dynamics of ice melting in the sea or in glaciers in a way that characterized what in fact we've seen to happen. And that is, it's melting much faster than anybody believes. So the report, the IPCC report, talks about a very small sea rise even as late as 2100. That's no longer the case. And this chart here shows you the average model run is shown in red. Come on. And this is the difference from the mean extent of ice. And, you know, it showed that there should have been maybe a, come on, Arrow, where are you? Why do you hide? There should have been a maybe 5% drop, and there's a 20% drop. And that is due, it is believed, and there's your 20%, from the fact that in these ice sheets, there's water that gets underneath the sheet and lubricates it so that it is so that it melts from below. And that's a process that has not been modeled and clearly goes faster than expected. So now I'm giving you one person's view. This is Joe Rome, who's very concerned about it and an expert in climate. He expects 4 to 5 Katrinas every year from this, and that's because if you heat up the air over water, that is in fact the driving force behind hurricanes. Expects a 0.5 to 1 meter rise in sea level by 2050. Well, that'll wipe out most of Bangladesh and other low-lying areas. It won't be terribly good for us either. So the argument is, let's do something fast. There's a growing view that we need to hold temperature increase to less than 2 degrees C if we're going to avoid some major impacts. I would say if we could hold it to less than 3 degrees C, that would be a major accomplishment, and we can cross our fingers and hope we'll be okay. This is a complicated chart, and I want to get to China. So let me do this quickly if I can. These show the trajectory of CO2 emissions, which relates to energy use, associated with certain temperature increases. And what this shows, if you look at the green, is that we have to decrease our emissions right away and reach, you know, get down to 0 by 2100. No emissions. Well, you know, energy drives our economy, and getting down to 0, even by 2100, would require remarkable things. Or if we look at the yellow, which is maybe 3 degrees C, this too requires that we reduce our emissions, although we don't have to go so low, quite so low in the long run. Okay, well, what in fact have we been doing? Well, first of all, I'm going to skip this. There are, well, this is worth looking at. UNFCCC, the United Nations group that negotiates on this, has this as the target, which means decline in emissions. And Jim Hansen, who's one of the leading climate scientists in the US and the most outspoken, believes that we have to stay below 2 degrees C. And so he's arguing for 400 parts per million of CO2 equivalent in the atmosphere. And there is no scenario that's been run that gets you that low. Past trends. Remember what I showed you? This all has to go down. It's all going up. This is energy use, which equates to CO2. You get the most CO2 from coal. You get the second most from oil, and third from gas. Oil gives you maybe 70% as much as coal, and gas on an energetic basis gives you maybe 50% as much. Nuclear does not give you CO2. Hydro doesn't, and biomass depends on how it's used. But look what's going on. You know, to avert the disasters, this has to go this way. It's going this way. And indeed, if we just look at the last 35 years, emissions increased by 70% globally. And the common forecasts project a 55% increase in the next 35 years. So everything's going in the wrong direction. Okay, now let's turn to China. China has shown a dramatic increase in CO2 emissions in a 4-year period from 2002 to 2006. Business as usual. The major forecasts suggest that China will be responsible for roughly half of incremental CO2 emissions between now and 2030. Roughly half of all additional emissions are expected to come from China. It's important to understand a little bit about China to understand what can be done about it, and that's what I'm going to try to spend the next part of my talk on. Do I have to end rigorously at any particular time? Okay. You guys have all day? A week? Okay. Well, in China, I'm going to talk about it in 3 parts: glorious history, energy crises, and the future. But actually, even before that, after the Communist Party took over in 1949, they adopted a model similar to that of Russia, and that is resources were virtually free. Don't worry about the environment. The important thing is to make essential commodities available to people, and energy was an essential quantity. And build heavy industry as fast as you can. And that was the way they did it for 3 decades. And then something truly dramatic happened, and revolutionary, not only for China but for the world. And I want to talk about what happened. And that was 79, 80. And it happened just in time because by then China had was getting a fairly good-sized energy system, and they did something no other developing country has ever done. So the first period Well, basically, this is GDP, gross domestic product. This is energy, and you can see that energy is growing much faster than gross domestic product. And in fact, there was a widespread belief that for a developing country, that's the way it works. They get more industry, they get more houses, has to grow faster. It propels the economy. Well, in 1979, a group of about 100 energy experts in China got together for a serious study, and China continually experienced energy shortages, even though energy was growing fast. And they basically said, you know, the crisis in China is not an energy, it's an energy policy. And that China could not continue to have energy grow twice as fast as GDP. And in fact, after a lot of arguing back and forth and discussions, they recommended strongly to Deng Xiaoping that in his proposal to quadruple GDP in China, quadruple the economy in China in 20 years, that he state that they're going to have energy grow half as fast as GDP. Now, that wasn't made known outside of China, but in fact, that was the policy decision. Why was it? Well, China, energy is a large source of pollution, the largest, maybe 70% of the pollution necessary to quadruple GDP. I mean, they're strangling anyway, but imagine how much worse it would be. The other thing is energy is extremely capital intensive. And so you can take money and build a power plant, or you can take money and build a hospital. And if you can figure out how not to build that power plant, then you have money to build the hospital. And so there's real competition for capital. And they argued that to Deng Xiaoping, and interestingly enough, he fundamentally changed their policy. So what'd they do? Well, they did everything they could think of, and they did it fast. They put energy quotas on factories. They put in monitoring systems. They promoted energy efficient technology at the factory level. They closed down a whole bunch of factories that were truly outmoded. It wasn't hard to find outmoded factories in China in those days. Financial incentives. They set up a national program to invest in efficiency. In those days, it was a state-run economy, and they could actually give grants, and they did initially, and then over time, they converted it to low-interest loans of substantial proportion. And so they created an entire apparatus that was focused on investment in energy efficiency. They had the China Energy Conservation Investment Corporation, and it had branches all throughout China. And its job was to evaluate projects, and banks had money set aside for efficiency. I'll show you in the next chart how significant it was. They did some R&D for the first time. One of the other things they did, they set up energy conservation service centers throughout the country. They put in place 70 centers and trained people to be energy conservation experts for their city or their province. And they did that overnight. For example, this chart on investment, the red line shows efficiency as a share of total energy investment. And bear in mind that in 1978 it was 0. It wasn't defined. You know, there might have been a little bit going, but there was no system. Within 2 years, they had an entire system in place, and they had, well, by 83, 12% of all energy investment was going to efficiency. And that's remarkable. No country's ever done that or come close to it. It's hard to find efficiency to invest in unless you have a system that does it. So what happened? As a result of all these things, instead of, this is actual energy consumption, and this is our somewhat reduced estimate of GDP growth. We think they were somewhat exaggerated in this period, and energy grew at less than half as fast as GDP. Amazing accomplishment. No other developing country sustained that sort of activity. I could tell you a lot about things they did, and they did that in spite of increasing saturation of various equipment. Okay, well, unfortunately, and here you see it again, there's GDP, there's energy, the period 1980 to 2005, but it masks what happened after 2000. And here's why we worry so much. They had a target for energy. In 2000, they repeated Deng Xiaoping's idea of quadrupling GDP in 20 years and just doubling energy. And so we can draw a line, and this is energy on the left, and here's the target. And look what happened. It went, in a matter of 3 years, they got, well, 2/3 of the way to the 20-year target. Unbelievable. Let me show you what else. This is what the projections were of China's CO2 emissions, and here's what happened. And so they caught up with us by 2005, when in fact every forecast, both within China and outside of China, missed this. Nobody thought this was going to happen. The projections were it would be 2020 before they caught up with us. In terms of global effects, if you look at this, here's China's growth, here's the global growth. China is producing, in those years, was producing probably 60–70% of the incremental CO2 emission in the world. Adds 2 power plants a week. Many people have heard about this. Let me compare that with a forecast that the International Energy Agency made for the period 2003 to 2010. They expected the world would have somewhat over maybe 225 new power plants in that period of time, and they expected China to have 150 of that. So that's a huge proportion. However, China built 100 of those gigawatt power plants, 1,000 megawatt power plants, in 1 year. And they did that in more than 1 year. So my guess is, and I haven't added it up, but I think up until now in this period, China probably has built, well, they built 700 megawatts. And the rest of the world has built less than 100 megawatts. So something really dramatic happened. What happened? Well, here's China's steel production in 100 million tons. And I drew the forecast. This is what the Chinese expected would happen in the yellow. And this is what actually happened. So instead of 250 million tons, they produced 500 million tons in 2007. Double what they thought they would in an incredibly short period of time. Cement production. Is this discouraging? Worrisome. 1.4 billion tons. We produce less than 100 million tons of cement in the US. Let's look at cement. India makes 6%, the US makes 4% of the world's cement. A bunch of countries make 2%. A lot of countries make less than 2%, you know, a whole lot of countries. And China makes 50%. Okay, well, something dramatic happened, and what happened was China joined the WTO. China decided that markets were the way to go, and they completely dismantled, almost entirely dismantled their energy efficiency apparatus in government. They dismantled the detailed energy data collection apparatus because they were convinced that the market would solve all these problems. And there was a huge amount of money to be made in construction. And construction is what drove all this. In addition to which, China did embark on a very big program to improve the quality of housing in the country. And they just lost track of energy efficiency. That came to the attention of the highest levels of the government. And in fact, a very close colleague of mine got invited to the Politburo as the outside expert, and he was asked to advise on what China should do about this. And this was his advice: set a mandatory target of 20% intensity reduction in 5 years. And the Chinese government adopted that in every way possible. It started from the Communist Party, and the Communists, I was amazed. I read this summary of the Politburo, and I didn't know what was going on. And the Politburo only puts out an economic plan. You know, we want to quadruple GDP. They don't get into details on anything else. The government does that. If the government doesn't do it right, the Politburo can replace it. Well, they got into the details of energy. They were worried. And that has been their goal. So I'll tell you later. Well, I better tell you now. Man, I have so much more to show. Can't do it. Well, they're doing everything in the world. They chose the 1,000 most energy-intensive enterprises, not facilities. An enterprise can be a collection of facilities, representing 60% of all industrial production. And every one of those enterprises has agreed to a quota over that 5-year period. A lot of them have complained about it because they didn't take any time to really figure out what made sense in many cases. They just told them they had to do it. They've gone around the country closing inefficient plants, and that has also had a great outcry. These are politically difficult things to do. They have differential pricing. When they started in 2005, they discovered, because some of the provinces can do their own pricing, that provinces were subsidizing energy-intensive industries. Well, that's been eliminated. And now an energy-intensive industry, if it is less efficient than the average that's expected, can pay 2 and 3 times as much for energy as they otherwise would. These are very strong policies. The energy conservation centers are now being built up again. The government fund for investment in energy efficiency, I went around after we discovered what was going on and made some proposals. I had no idea if they would be accepted, but we did some analysis. And I thought $10 billion would be a good amount to start. And that's what they have. $10 billion for efficiency investments now, and growing. government reorganization. They've now created the National Energy Conservation Center. They've now put in a whole new bureau within the Ministry of Industry that never existed before, focusing only on energy efficiency. This one vote veto is very interesting. This means if you're an official and you're responsible for meeting the quota and you don't do it, and you can't demonstrate that you've done a serious good faith effort, you can't be promoted, you can't get a bonus. It doesn't matter how well you've done it, everything else. And that applies to the governor of a province, to the head of a factory, and to the people down below. Now, they haven't done it yet. They say they're going to exercise it next year because they think the data are good enough. So they're putting a lot of pressure on people. They're actually starting to enforce building standards. That's a weak area for them. And they have very tough fuel economy standards, tougher than the US. Now, they're not going to get the full 20% intensity reduction. That was an astoundingly tough goal. But they are on a path to get 15%. For the whole economy, that's for everything. The whole energy economy now is 15% less energy intensive, will be in 2010. Okay. I do want to tell you a couple other things that I think are important to realize, and then I'm going to conclude. Many people think that energy prices in China are too low, and that's a very familiar refrain by companies that feel it might be unfair competition. Turns out energy prices in China are by and large at international levels. In San Francisco, we pay a lot for electricity. Guangzhou pays more than we do. Pays 16 cents a kilowatt hour. Natural gas prices, coal in China overall is more expensive than in the US. Oil prices lagged international prices by maybe 10%, and now they're catching up. Now, this is in sharp contrast to what it was in 1990. This shows you what's happened to the prices to get an idea. So you realize it's really been since 2000. Part of the reason the prices were allowed to go up so much is that the Chinese thought prices alone would solve their problem, when in fact those of us who have worked in energy efficiency a long time think prices are important. They're a necessary but not sufficient condition. You need policies because people can't figure out what to do on efficiency. Some people may think China's profligate in the use of energy. They're not. They use 1/8 as much as we do. In terms of, while China has caught up with us in emissions for the whole country, per capita emissions are very much lower than the US. And that's not even the relevant quantity, because it's the cumulative emissions that cause the concentrations, because that stuff stays in the atmosphere for a century. And if we look at cumulative emissions, there's China at the bottom, and there's the US. So there are people in this country who want to blame China for the problem, and China's a late comer to this. The 20% intensity reduction target represents, if they get 15 of the 20, a greater reduction in CO2 emissions than the European Union has promised under the Kyoto Protocol. Now, this is compared to different base cases. So in China, there's a growing base case because it's assumed that the natural situation is a growing base case. But the reality is China has, in this last round, done a huge amount to reduce CO2 emissions, while at the same time continuing to grow them. People think China is less efficient, inefficient, and growing less efficient. Well, these charts, I don't have time to show you, but they're all energy use per dollar value added, and with one exception, they're all going down in these these periods. Okay, on coal use. You hear a lot about coal in China. Well, on a per capita basis, China consumes half as much coal as the US does. And the other thing that's quite surprising is that China's resources for coal, known discovered resources on a per capita basis, make it not terribly rich in coal. They're going to have to import coal if they're going to keep using coal. We hope not. Okay. What do we do about all this? I think there are solutions. And I think, first of all, we have to recognize that we need new energy supply technology, but it takes a long time to achieve results. But we're not going to solve the problem without carbon neutral energy supply technology. We have to have it. And that means if we're going to have it, and this chart points out, Royal Dutch Shell points out, it takes 25 years after commercial introduction for a primary energy form, energy supply technology, to obtain a 1% share of global market. Well, we have to do something about that, but it does take time. So we've got to invest large amounts of money and training of people to work in photovoltaics, wind, solar thermal electric, improved nuclear, CO2 capture and storage, fuel from biomass, anything that is reasonably possible in a 25-year period. In the meantime, the biggest activity that's needed is energy efficiency, because that's what we can do while we're developing the low carbon supply technology. The industrial world has to reduce its energy use, and I believe it has to support developing countries so they can figure out how to reduce their energy use. And we're in the middle of working with the Department of State to design a program for China that might be $500 million to $1 billion a year in supporting creating policies for energy efficiency in China as the single most effective way of reducing growth of CO2 emissions. And I think that I know that China will be growing because they're building out their infrastructure right now. What I would point out is that China will, in time, saturate in their building stock, saturate in their appliance stock. They've already saturated many appliances in urban areas. And at a point in the future, they're going to look like us. And they'll be able to constrain growth as well. I'd say, and we're trying to calculate right now when we think that would be. And that's a very hard estimation. Depends on a lot of parameters, so there's no one answer. But maybe the next 20 years. And so what I'd say is what China does in the next 20 years is in many ways going to seal our fate. If they double energy use and industrialized countries can diminish energy use, and we can develop supply technologies in that period of time, we can make it through. Not at the level that Jim Hansen and others might wish, but maybe 3 degrees centigrade. And maybe we can avert huge amounts of melting of ice. If China triples or quadruples its energy use in the next 20 to 30 years, we can't make it. It's that simple. So what do I think will happen? Well, I'm hoping that we work together with them, and I have a lot of confidence in the Chinese to achieve great things. They did it for 22 years between 1980 and 2000. My final comment is, why do I have confidence that this may happen? Because there are some exceptional skills in China that you just don't find in other places. Great creativity. I saw it all in energy efficiency, but you can find it in other places too. He works hard all the time, but he does need to rest occasionally. Good breakfast. And now my favorite, if you've been to China. Okay, thank you for your attention.